Assalamualaikum and good day students. Topics for today is about uniform circular motion and centripetal acceleration. Uniform circular motion refers to the motion of an object traveling in a circular path at a constant speed. In this type of motion, the object maintains a uniform distance from the center of the circle while continuously changing its directions. So example of uniform circular motion include a car driving along a circular track, a planet orbiting around the sun, or a fan blade rotating at a constant speed. So understanding uniform circular motion is essential in the various fields, including physics, engineering, and astronomy. So here will be described in terms of the angular displacement, angular velocity, angular acceleration, and then the analog to the main concept in linear motion. In this slide, you can see these are the relationship and analogies between angular and also linear quantities. So from here you can see the formula to find the displacement, average velocity, and also the acceleration for linear and also angular quantities. So here is the details of the formula to find the angular displacement, average angular velocity, and also the average angular acceleration. The radian is a unit of angular measure. So the radian can be defined as the arc length S along a circle divided by the radius r. So to convert from revolution per second to other angular units, you can use the following conversion factors, which is 1 revolution per second equal to 2p radians per second, and 1 revolution per second equal to 60 revolution per minute, or RPM. So here you can see the formula to find the radians is equal to S divided alpha, and 1 radian is equal to 57.3 degrees. Some key characteristics of uniform circular motions are constant speed, which is the object moves around the circle with a consistent speed, and the magnitude of the velocity remains constant throughout the motion. However, the direction of the velocity factor changes continuously. Meanwhile, for centripetal acceleration, to maintain circular motion, an object must experience centripetal acceleration. So this acceleration is directed towards the center of the circle and is responsible for continuously changing the object's direction. The magnitude of centripetal acceleration can be calculated using the formula A equal to V square divided R, where V is the speed of the object and R is the radius of the circular path. Here is the example of velocity directions. So as you can see in A, the disc rotate counterclockwise. The direction of the angular velocity is out of the page. And in B, the disc rotates clockwise. The direction of the angular velocity is into the page. In uniform circular motion, the object is traveling at a constant or uniform speed on a circular path, and the period t time it takes to make one trip around the circles, and the circumference is the distance around the circle, while c equal to 2pr. So here you can see the formula to find the v, which is speed, and also the c. C here is the distance here, and then the t is time to complete one circle. So the condition of uniform circular motion is the speed is constant, velocity is not constant, and velocity is always changing, and meanwhile this acceleration is centripetal acceleration. Centripetal acceleration is the acceleration experienced by an object moving in a circular path. It is directed toward the center of the circles and is required to keep the object moving in that circular path. The magnitude of centripetal acceleration can be calculated using the formula A equal to V square divided to R. In centripetal acceleration, you can draw the two velocity factors so that they have the same tail, and the factors with connecting the head is delta V, and draw the triangle made by the change in position, and you will get the triangle in V. Since the triangle have the same angle isosceles, so in centripetal acceleration they are similar. Delta V divided V equal to V delta T divided R. So now a delta V equal to V square times delta T divided R, and then delta V divided delta T equal to V square divided R is equal to as AC equal to V square divided R. At any given moment, V is pointing tangent to the circles. AC is pointing towards the center of the circles. So if the object suddenly broke from circular motion, would travel in line tangent to circle. Forces causing centripetal acceleration. So in Newton's second law says that the centripetal acceleration is accompanied by a force Fc equal to m times AC, while Fc stands for any force that keeps an object following a circular path when the tension in a string, gravity, and force of friction. Here is the centripetal force example. So a part of mass m is attached to a string and its weight is supported by a frictionless tables. Then the tension in the string causes the part to move in circle. Here is the general equation centripetal force. So if the force vanishes, the object will move in a straight line tangent to the circle of motion. Centripetal force is a classification that includes force acting towards a central point. It is not a force in itself. A centripetal force must be supplied by some actual physical force. So here is the summary of the formula for linear and angular of the displacement, average velocity, and also the accelerations that you should know and remember. Here is the example of the question for the centripetal acceleration. So a 2000 kilogram car runs a circular turns of radius 20 meter. If the road is flat and the coefficient of friction between tires and road is 0.7, how fast can the car go without skidding? So given that the friction is the only force pointing towards the center of the circles, and it alone supplies the centripetal forces. So guys, you can try to answer the example of the questions. Okay, so that's all for this chapter. Thank you. Bye.